Hey guys, I keep trying to play this video, make this video, but it's not letting me do it. So I was going to play a video, but I'm going to go ahead and just read this piece out to explain kind of an idea. So here's water prorector. But basically, the idea here is that I have this sensor, well, this board here. And what I can do is basically use like this board to bring a connection between like the real world, like out here. So like liquids, you know, like water, coffee, whatever. So I can like take, basically the idea here is to like, I'll show you kind of like simply, pretty simple actually, concept. You would basically just take like two wires. This is obviously not like exactly how it would work, but you take two wires like that, and so you make a little circuit, and you literally would like stick the sensors into the water like that. So the way I do this is basically going to you cycle the voltage, and so basically that's it. That's the water sensor that I'm designing to do. It's this, I'm going to have to make it more fancy than that. But basically what we do is we use electricity. We flow electricity through the water. I mean, in this case, coffee, but it doesn't matter. And we cycle the voltage, and we do that. We reduce and oxidize metals of the electrodes, just like we do in our cells when we metabolize stuff. And then what happens is when we do that, let me take these out here. So we have these electrodes, right? They go to the water, and then I write a program in the computer to basically plot the voltages. So that's going to be, I'll read this later. It's a little like poem for it, but basically what I'm going to do is use Arduino. And what I'm doing now is installing the web plugin to like, what I'm going to do is basically write programs to put onto this chip here, and that chip is a controller. Like, it's like a little microcontroller they use in like a lot of machines now, and this is like $10. So this entire kit right here, like this thing and this thing, was like $17. And I mean, the little wires like are, you know, basically inside the kit. So again, like I want to show, if you're just tuning in, basically what I do is I have to set this up, but I'm just basically installing the software programming environment for let's see, hold on. I can't remember my fucking password. There it goes. So let me refresh this. So all right, so if you're just tuning in, what I'm doing is I'm installing the software package for this sensor chip, and I'm going to be measuring, like trying to measure the electrochemistry of coffee. That's my project. And then this is, eventually what I'm going to do is hook this. This is like $10. I'm going to hook this initially to like this fancy computer here, write the code of like Arduino in the programming. That's going to send the code to this thing, and then this thing is going to be like, I'll show you again, like just so you can see it. This thing right here literally sends electricity into the coffee, like this. So like, I pop that in there. So like that. So I'm actually using the coffee, or I'm like, what I'm going to do is measure metals in liquids, like in the boundary waters and in the mining ponds and in the oil residues, using this Arduino chip. And so you can see that. So it's basically a sensor. And then what I'm going to do is make a field sensor. So instead of having it connected to this computer here, which is plugged in, I'm going to have it hooked up to this tablet. And this tablet is $30. So it's really like a nice Android tablet you can get really cheap. And you can run Arduino code on Android. So this will be connected to that. So it'll be portable. I might even just unbox this to sort of show you. Bear with me a little bit. Let me... Hi. There we go. So to give you an illustration, Alright, so what I take is this thing here, and I hook it into this, like that, and that's my tablet, right there. And then I take the cord of the Arduino, and I plug it in like that. So basically, now this right here, like that, is a water sensor. See that? And what I'm going to do is push this back a little bit. So I got the water here. So basically what's going to happen is what I want to do is actually maybe like you do weird things like make music out of it, you know, put your, I don't know, it's be crazy. Let's just start with the basics. So basically turn this around. So like you'd have your sensor, push this back a little bit. So you've got your water here, and you've got your computer, and then your sensor like that. So basically you're going to stick the Uh, yeah. All right. So this is like the basic, this is the basic setup. So it's really simple, actually. This is electrochemistry. So what we're going to do is making a program to, it may be a little more complicated than this, but the basic idea is this, that the electrical energy in the sensor, or like the electrical energy in the sensor, we're going to sweep the voltage, and when we do that, we reduce the metal ions in the water. So like, there's lots of metal in the water. There's metal in the water, like in like Flint, Michigan, there would be lead. In other ways, they're like iron, cobalt, copper, like mining. In the arsenic and like mercury stuff. So all these different metals have different reduction potentials. And what this basic setup will be, you can even, solar power this. This is like $50. Like this hardware here is like dirt cheap. So basically what I want to show you is that there's like on this, if I go here, like this, I'm gonna like open it up, but all right, so this this public lab website, let me put this over here. So you see that, I'll be a little careful, but so there's like this potentiostat, and so like this page is an environmental like sensor website. It started out when the Gulf oil spill occurred in like 2011, and this potentiostat is for measuring electrochemically active compounds and microbes in water. So you can even look at like bacteria. And the basic idea is that this is like a public, like environmental protection, like website. So it's like they're all working together throughout the country, and they have this like community of public lab water quality people. It's a community, and then there's like links to other public lab electrochemistry wikis and research notes. And I'll just read this out. So the design and construction of operation of a low-cost open source. Let me put that in there. Yeah, let me read it out loud. So the design, construction, and operation of a low-cost open source potentiostat, the WEStat, has been described in a number of public lab wikis and research notes. Links to some of these pages are provided. Potentiostats can be used to test for electrochemically active compounds, in other words, metals or microbes in solution. So like if you have a microbe in here, even you could do this, or water. It's really interesting. It's actually a really elegant technique. So like big thing is tracking heavy metals in waterways. The cheapest like potentiostat commercially is like $1,000 on the cheap side. So there a lot of like, there's been a lot of work to basically make something cheaper, because like tracking heavy metal concentrations in waterways is really important, and various accidents like Flint have led to like basically people's like don't have a lot of money to be compromised. And so this is like it says an inexpensive battery powered potentiostat communicating over the cellular network perhaps, or merely just recording onto an SD card, might be able to track relative fluctuations in the concentrations of these metals, making monitoring of this easier. So that's basically what this Internet of Things that I've been talking about is. And so even like this thing has Bluetooth. This thing has Bluetooth on it. So, and if I do it on a phone, like I can hook it up to a phone, and just as easily, like, you know, if I do this, like I can pop this in here to show you. So I could do that just as easily, and like measure the water with my phone, you know, and then I can like do data. I can send data to the web, you know, like really easily, and that's what I want to do. You know, I think that I want to start out with like a tablet that's cheap. You know, this is like $30, and work with like Wi-Fi. Get to the where I could do it like with the cell towers. But I mean, just to show you like this device itself, you know, how small it is, you can see. And so yeah, I think that I just wanted to show that. And then the basic idea next is to, let me show you on the next step. So once we've done that, we're going to go to like Google Earth. And actually a lot of this stuff, like with data science, like a lot of the mapping has been done, you know, like already. And there's a lot of data on elements, like in Google Earth, or like other things like GIS maps, or global information systems. But I like Google Earth because it's just like a really visually appealing and interesting program. And so what we're gonna do is like connect this. Like what I want to do is basically put like. I'm going to show this. Well, put this over here. Pop that in there. You get the idea. So like put like chemistry from the water into the computer and onto Google Earth. So does that make sense? Like from water samples that I take somewhere with a phone that has GPS, and then put the data onto Google Earth. So, or like another map, like Google Maps. So that's the basic idea of what I'm calling wiki arsenic. You know, water is sanity. But I just wanted to show you that. And there's like a lot of like wires and stuff that, you know, it's not that hard, but you know, it's not simple either. So. But we like it hard. So anyhow, yeah. And so basically, if you're tuning in, the idea here is to like put in like an alternative to getting frustrated with like big oil or like mining. It's like if we just show them the data that like what their water looks like from their fracking and shit or mining, like it's just we show the public, right, on Google Earth. And I think it's going to be good. So I'll just leave it at that. But let's see what we could do here. Skip. So we're going to White Earth, Minnesota, right there, and here we are. We're gonna load in. So here we are in White Earth, Minnesota, and you can see that we're just like traveling, right? Oops, zoom out. So like all these lakes have water, right? And so what I want to do is actually look at this one. All right, so this is a waste site from taconite mining, and this is like in Bear Bay. It's like the result of a really big lawsuit where what happened was, this is Lake Superior, so like all like here, like on this side of the lake, and like really all around it is like really iron, like copper, nickel, sulfide mines, or sulfide minerals, and like there's arsenic, mercury, heavy metals. So what they were doing was like mining all around here and just dumping it all into the lake. And what happened was eventually, like in this, like they were doing this a lot for many decades, and then eventually people in Duluth got sick. They got sick from like the water having like bad minerals or like metals. So from the mining, just put in the Lake Superior. So there was a huge lawsuit, and what happened was the Reserve Mining Company, which became the North Shore Mining Company, got forced to build this thing, which is a huge waste pond. And so now they dump all their taconite waste in here. You look at it though, just get close to it. All right, see how like it glows in the dark, like almost on the map? So to a satellite, when you zoom out, you can actually see how freakish that thing is. Like this is a normal lake right here, like that color, that is the waste pond. So I would like to be able to compare, like look at the waste of this water between the Bear Bay waste pond and this one or this one, using like this sensor. So like get water from there or water from there, put it in the cup, measure the electrochemistry, and then put it on Google Earth. So like I would actually take the water from that, put it in here, measure the electrochemistry, look at the metals in there, and then put the data back on the map. So I hope you can see that. So the idea is actually go to the site, hike into the site, get the water, put it in a cup, do my measurement with my electrochemical device, run the electricity through the water from that pond in my cup, and then I take the data, and then I go to my cell phone or tablet. This has Bluetooth, and I can just Bluetooth it to that, or I can directly hook this up to that. Either way, it doesn't matter. And then the cell signal this cell phone has GPS in it. So when the data comes into this phone, then it's going to be marked with GPS, because that's where I will have taken the water from. And then I'll get the data and I'll put it on a new map so it's like a cycle. So basically the cycle is water. I hike into this site, collect that water from this toxic waste pond. I put it in a cup. I can even do that on site. That's the nice thing about this device, because this is portable. It's solar powered. You can run this off a really cheap hiking solar panel. This is a low power tablet. It's super, super cheap. I mean, this is $30. So this is like a low end version. I don't really care. I want water protectors to be able to do this like really cheaply, but I want it to be high quality, And so it's going to be like playing with the whole thing. But basically the basic idea is for then, once you get your sample from the pond, you make an electrical circuit, you measure the voltages using the potentiostat, which is here, using electrochemistry. So like this is the electrodes, you measure the voltages with your potentiostat, and then you get the data, geotag it, and it goes back to the map. So I hope that makes sense. But